Our understanding of the world is shaped by our beliefs. And when something hasn't been proven yet, the question remains, what is the truth? Today we're revisiting the discussion on the age of the solid inner core, and we're looking at an article from 1987. Yeah, we're in the winter time again. Already, I think it's too early. But the crazy thing is that this is, the Northern Light season has started, and we can see we've already, this year there's been so many Northern Lights already. Yeah, so it's quite wintry already. Yeah. So, if you didn't know, my name is Asta. I'm a geologist living in Norway. And on this channel I talk about anything geology related. So if that's something that interests you, join the club. But now let's see what's in the cave today. I've touched upon this subject 3 years ago, and I really wanted to revisit it. So I will take you with me on my investigations. The article we are looking at today is called Paleomagnetic Data Suggest a Link Between the Archean Proterozoic Boundary and the Inner Core Nucleation. It's written by a guy called C.J. Hale in 1987. The general belief today in geology is that the Earth's magnetic field is caused by a geodynamo governed by convection in the outer core. When this article was written, geologists argued that the inner core formed only a few million years after the accretion of the Earth. What Hale points out that the question of, now I'm quoting him, the question of timing of core formation reduces to a question of a balance between the rates of heat production and transport out of the early Earth. End quotation. But what ponders scientists is, how is the core still alive after 4 billion years? Hale recognizes that the plausible reason can be that their inner core keeps growing. But the groundbreaking idea that Hale expresses in this article is that the paleointensity measurements could aid in determining the age of the inner core and support already made core dynamo models. So what does the data say? At first glance, when Hale looked at the samples from the different places, they looked confusing, but let's see the figure he made. I will put it here, I think. On the x-axis you have the age of the Earth, and on the y-axis you have the paleointensity. As you can see, there's a clear trend from the samples taken, and it peaks around 2 billion years, just around the Archean and Proterozoic boundary. Another article written by a guy named Stevenson in 1983 had made a numerical model calculating the normal field strength up towards time. And as you can see, it makes a dip at around 2 billion years. So Hale's idea gets supported by Stevenson. Hale concludes that it could be evidence that the Earth's inner core nucleated at the beginning of Proterozoicum, and it would explain, for example, some other of the other geological events happening at this age. But of course, he also concludes that more samples and investigations are needed to be done. Yeah, but if we would just reflect about the article that I talked about ages ago by Tarduno in 2007. The cool thing about this article is that it used a new way of collecting measurements of paleo intensity from Archean age. But when it comes to their arguments for an early nucleation of the inner solid core, I don't really follow. They say that the magnetic field, by their measurements, was 50% of today, and it would have been strong enough to protect against solar wind. But I don't agree that this necessarily leads to proof for formation of the inner solid core. For me, Hale's arguments, even though it's an older article, still holds, but nothing has been concluded yet. It's a discussion that is still alive today. But that's what I got this time. Thank you for watching so far, and have a rocky day.